For today's lesson, our focus standard comes from Grade 8, Functions. Topic A, Define, Evaluate, and Compare Functions. The topic for this video lesson comes from Mathematical Models, Slope-Intercept form. Our essential question for today is, how does the linear equation relate to the table and the graph? Please take a moment, pausing the video if you need to set up your header. Be sure to include today's date, set up your question column and your note column, and resume the video when you're ready to begin. So we've been talking a lot about mathematical models and now in particular linear models, and so we're going to stick to discussing linear equations or linear relationships. And so in the last video, we were analyzing linear graphs. We said there's basically three questions that we ask. Is it increasing or decreasing? How steep is the line? And we referred to that as being the rate of change. And then lastly, what is the starting value? We said if you can really describe these three things, then you're giving us a really good picture of this linear relationship. And so now we're going to put more specific language to it. These first two questions, is it increasing or decreasing, and how steep is the line, is actually two questions that we refer to as being the slope of the line. The slope of the line, or also referred to as the rate of change, will tell us if it's an increasing or decreasing line and how steep it is. When we talk about the starting value, what we're talking about is the y-intercept. Intercept means where it crosses. So it's where it crosses the y-axis, and that would be the starting value. So when we're describing linear relationships and we're using their equation form, we use a pretty standard equation, and it is called the slope-intercept form. So let's talk a little bit more about that. The slope-intercept form as an equation is y equals mx plus b. So y and x are the two variables that we're measuring and comparing against each other that make the linear line. The m value, right here in front of the x, the coefficient in front of the x, is referred to as the slope. And again, that's also sometimes called the rate of change. And that's where we first saw this equation, where we measure as a ratio, which makes it a rate, the change in y divided by the change in x, but we oftentimes leave it in the fraction form. And then in seventh grade, you may have heard this referred to as rise over run, and this is really, really common. But I like to use the more precise language, the change in y over the change in x. And that's what we see as the m value. That's what that represents. This b value, that describes the starting value, or the y-intercept, where the line is going to cross the y-axis. So by knowing just the slope and the y-intercept, you're answering these three questions, and we can write it into the equation, y equals mx plus b. There's a helpful piece of information I want to give you before we move on any further in today's lesson. And you may have already seen this poster, but I have a poster of this in my classroom, and this is who we refer to as Mr. Slope Guy. And Mr. Slope Guy is an illustration that someone came up with to show us the four types of slopes. So his eyebrows here are giving us the first two. If it's increasing and rising up as we read from left to right, then it's a positive slope. It's increasing. If it's decreasing as we go from left to right, it's going downhill or a negative slope. So I here saying, well, this is a negative slope. Those are the first two. A vertical line, you might think of the y-axis, is what we would refer to as undefined. That has an undefined slope. And a horizontal line, like the x-axis, has what we refer to as a zero slope. So they use these on the corner of his mouth here, which is making a straight line to remind us that that's a zero slope. So Mr. Slope Guy may be handy for us to help as we go through looking at the four main types of slopes that we have: positive, negative, vertical undefined, or horizontal zero. So now we're going to dive in to looking at two different graphs and seeing if we can write the equations for them. Here's our first equation. Y equals 2/3 x plus 4. Here we see it as a table of values, and here we see it as a graph. So we've been doing a lot in class to see if we can find the relationship of where we see the slope and the y-intercept, where we see the connection of that in the equation, the table, and the graph. So let's take a moment. Let's start with this slope. We know that slope is the change in y over the change in x. So when we use it in the equation form, this is our slope. It is 2/3. So I'm going to fill that in here. The slope is 2/3. But we want to see where, that's where it is in the equation. Where can we now see that in the table? To do this, we want to identify, using those arrows I've been having you use, how much is x changing and how much is y changing. So let's go ahead and do that. I'm going to have you draw the arrows and then show how much is x changing from -9 to 0 and then from 0 to 6. And I want you to do the same thing for y. Draw in the arrows from -2 to 4 and show how much that is changing, and from 4 to 8. Pause the video to do this, and then let's compare our work. So let's compare. So here you can see I found on this side, the left side of my table, the x side, my change in x, and from -9 to 0 was +9, and from 0 to 6 was +6. And then for my change in y, from -2 to 4 was +6, and from 4 to 8 was +4. So at first glance, we're thinking, uh-oh, these values are all different, but remember, we need to look a little closer, and I hinted at this previously in class. So we need to set up these ratios, the change in y, so we're going to take it from the right side of our table, over the change in x, which is here on the left side. And I've highlighted them in the order, in the pair that they would belong to. So from the first changes, our change in y was +6, and our change in x was +9, so it would be 6 over 9. And for our second one, our change in y was 4, and our change in x was 6, so it would be 4 over 6. So we need to ask ourselves, are these equivalent? Is 6/9 equal to 4/6? And then ideally, is that then equivalent to 2/3? And so think about that for a second. Do you think that all three of these are equal? And if you said yes, I would agree with you. If you divide both 6 and 9 by 3, and if you want to write that out, you can. If you take 6 divided by 3 and 9 divided by 3, you're going to get 2/3. If you take 4 and 6 and you divide them both by 2, you're going to get 2/3. So all three of these are equivalent ratios, they're equivalent fractions. And so this table is the linear table that goes with this equation. And we can see the starting value here, because when x is 0, and that's where the y-axis is when x is 0, then y is 4. And that's our b value right here. And so the y-intercept would be 4. And we can see that now. So the m value is telling us that our slope is 2/3. We found that here in our table, although we had to do a little extra work and make sure it's in its most simplified form to show that. And when x is 0, this right here, and let's highlight that. That's very important. Oh, what color should we use? The 0, 4, that is our y-intercept. When x is 0, that's our y-axis. The y value is 4, the y-intercept. So now we've seen it in our equation and our table, and we want to make sure we can see it in our graphs. So I think the easiest place to start is the y-intercept. And we see that right there, it crosses at 4. Let's see if we can just bring a little more attention to that. So right here, that's our y-intercept, because it's crossing at 4. And now we want to look and see where can we see the slope. So I could really start anywhere, but I see that it crosses the x-axis at -6, and I'm wondering, can I go 3 and then up 2 and hit another one? We start here at 6 and I go over to -3. So from -6 to 3, that's running 3. And then can I go up? Can I rise? Is my y change 2? And it looks like it is, from 0 up to here. That goes up 2. And it looks like this continues. Let's go ahead and take a look. And so we start to see if we continue that, because we have this first one. So we see the change in y going that vertical change. That vertical change is going to be 2. And it rises up 2. 0 to 2, 2 to 4, 4 to 6, 6 to 8. And that change in x, that horizontal change, is going +3 from -6 to -3, and from -3 to 0, that's +3, and from 0 to 3, and from 3 to 6. And so that remains constant each time. And so we start to see that stairs. And so now we can, and it started where y was 4. That's that starting value. When x is 0, y is 4, so that's our b value. So there we see it in the equation, the slope and the y-intercept. The slope, although it takes a little bit more work in this table of finding the change in y over the change in x and reducing that all the way down, we see as 2/3. And we see when x is 0, y is 4. So let's take a look at one more and try the same thing. So here's our next one. Y equals -4x minus 2. We have it in its table form, and we have it in its graph. And so I want you to take a moment and see if you can, just from the equation, identify what is the slope supposed to be, and what is the y-intercept supposed to be. What is the m value, and what is the b value? So go ahead and see if you can fill that in, and then pause it to do that, and then resume the video when you're ready to check. So let's see, what do you think? So the m value is always the coefficient right before the x. That tells us our slope. And since the coefficient in front of the x is -4, my slope is -4. But we're used to seeing it so far in a fraction form, and so the way to make any whole number into a fraction is to put 1 in the denominator. So this must mean that the change in y is -4, meaning it's a decreasing 4, and the change in x is increasing 1. And then my b value, the number that stands by itself, this subtraction sign actually tells me that this is negative. And so this is my y-intercept is going to be at -2. It's going to cross the y-axis at -2. That's my y-intercept. And so let's go ahead again and try that with the table where we found the change in x for these and the change in y, and then we want to set up our equations and see, can we see equivalent rates of change from the change in y over the change in x. So go ahead and pause the video and then resume the video when you're ready to compare our work. Okay, so let's take a look and compare. So I found my change in x and my change in y. And so my x values were adding 1 from -2 to -1 was adding 1, from -1 to 0 was adding 1. And then for y, from 6 down to 2, that's subtracting 4. And from +2 down to -2 is subtracting 4 again. So this one's really nice. We can see right away that that rate of change from the change in y to the change in x is the same. And so I've written that out here. And in its most simplified form, we're dividing -4 divided by 1 is -4, and that's the form we see in our equation. So there's our slope, our rate of change in the equation and in the table. And then we want to say, well, where do we see this y-intercept of -2? Where do I see that b value? And it's right here. When x is 0, y is -2. So now that we see the y-intercept of -2 and the slope of -4 in our equation in our table, we've identified it here. Let's now identify that in our equation, on our graph. So go ahead and see if you can find that. Go ahead and see if you can label where the y-intercept is and show that rate of change, that change in y and that change in x. And then resume the video when you're ready to compare. Alright, let's see. Does your graph look something like this? So we see that it has that negative slope, so we see a decreasing line. It's going downhill. And we see right here, I've now covered it up with a bunch of arrows, but it was crossing. If we look at our scale, we can see at this point was -2. So our y-intercept was crossing the y-axis at -2, so we see it there. And our slope, the y is changing by -4. So from 6 down to 2 is a drop of 4. From 2 down to -2 is a drop of 4. And for every drop of 4, the x was running or increasing by 1. So from -2 to 1, running 1. From -1 to 0, running 1. So there's our slope, and here's our y-intercept. So hopefully we're starting to see those connections in these three views. How to identify that slope and y-intercept in the equation, the table, and the graph. And that's going to complete our video today on slope-intercept form. And so please make sure that your notes are complete, that you have all of this filled in. We're going to want to refer to this and work with it more as we explore linear relationships in class.